Is it a strong, weak, or non-electrolyte? Well, first of all, we need to understand what an electrolyte is. An electrolyte is something that in solution, when it dissolves as ions. What do we mean? It means that in the solution, when it dissolves, there would be plus and minus ions. These ions then would be free to move. When this light bulb is plugged in, the electricity would move through the wire down to the electrode, and then the ions would conduct the electricity, and here's what would happen. We would get bright light because we've got lots of ions in solution. So, what kinds of things, when they dissolve, produce ions? So let's take a look. The most obvious thing would be something like sodium chloride. When you put it in water, it's going to dissolve. We say it dissociates, and it dissolves as sodium and chloride ions. So what do we have? We've got something that will conduct electricity. When we put it in water, we plug it in, and we're going to get a bright light. Why? Because there's ions that can conduct the electricity. What about if we put something like another solute in that's very common? What happens if we put in something like sucrose into the solution? Sucrose is C12H22O11. It's just regular old table sugar. Is this going to light up? Well, it all depends on how does it dissolve. And when sucrose dissolves, it dissolves as molecules. And so, because it stays together as a molecule, there are no ions to conduct electricity. So we say it's a non-electrolyte. Whereas sodium chloride, lots of ions. So this is going to be a strong electrolyte. All right, what other types of things are strong electrolytes? What other types of things give us lots of ions? Well, obviously, anything that's going to be like sodium chloride, that's a salt that dissolves as ions, that's soluble. So let's take something like potassium fluoride. That's very soluble. It's a salt, so that's going to be strong. What about something like silver chloride, though? If you check the solubility rules, it does not dissolve. It's insoluble. So this is going to be a non-electrolyte. It's not even going to dissolve at all. Okay, so other things other than salts. What happens if we put an acid into water? What do acids do? How do they dissolve? Well, when you put an acid like HCl into the water, it actually dissolves as ions. That's the unique thing about acids. They dissolve as ions. Well, it turns out that HCl is a strong acid, so it dissolves totally as ions. There's no molecules in there at all, even though it's a molecular substance. So it's very, very bright. So this is something we would call a strong electrolyte. Okay, let's try another one. Let's try something like HF. What do we know about HF? Is it in the list of strong acids? Well, it is an acid, but it's not in our list of acids. And here's what HF does. Hydrogen fluoride, or hydrofluoric acid, dissolves mostly as molecules. The H and the F have a fairly strong attraction to each other, so they stay together as molecules, and then a few of them will dissolve as ions. So we get a few ions because hydrogen, fluoride, they're pretty strongly attracted. The hydrogen and the fluoride are attracted to each other, so they don't come apart. And so we get a little bit of ions. It's kind of a dim light. Okay, so now we understand that the different types of things that can be strong, weak, or non-electrolytes. So let's just kind of come up with a list of things here. Let's take a look at some salts, and let's take a look at some acids, and let's take a look at bases. Okay, so we have salts like NaCl, KF, AgCl, Li, C2, H3O2. Now, would they be strong, weak, or non-electrolytes? If it's soluble, as in the case of sodium chloride, KF is soluble, and you need to check the solubility rules. But silver chloride is insoluble. Lithium acetate is soluble. Again, we would check the solubility rules. So these would be strong electrolytes. Those that are soluble. Silver chloride's insoluble, so it would be a non-electrolyte. What about acids? What about H2SO4? HNO3? What about H2SO3? Well, these are strong acids. So they're going to be strong electrolytes. H2SO4 and HNO3. H2SO3 is a weak acid, so it's going to be a weak electrolyte. Not many ions in solution. Bases? KOH. That's a strong base. Lots of ions. Going to be a strong electrolyte. Ammonia? That's a weak base. There's only going to be a few ions. Remember, ammonia will react with water a little bit. This only happens once in a while to give us ammonium ions and hydroxide ions. Because there's some ions, that's why it's weak. So acids, you need to know if it's a weak acid or strong acid. Bases, same thing. Weak acids, weak bases, those are weak electrolytes. Strong acids, strong bases, those are strong electrolytes. In the case of salts, if it's soluble, it's going to be a strong electrolyte. If it's insoluble, it's going to be a non-electrolyte.